In this lesson, we're going to learn about the three different forms of quadratics and what characteristics we can get based on each form. So the three forms we're going to talk about are vertex form, factored form, and standard form. All right, so starting with vertex form is f of x equals a times x minus h squared plus k. And vertex form will tell us two things. It's going to tell us the concavity of the quadratic, which basically just means if it is facing up or facing down, and it'll also tell us the vertex and axis of symmetry. So the letter that we're going to look at to determine the concavity is A. If A is greater than 0, or if A is positive, then our graph is concave up. If A is less than 0, or it's negative, our graph is concave down. So for the vertex, we're going to look at h and k, and h is going to be the x-coordinate of the vertex, and k is going to be the y-coordinate. And just like with circles, remember if it's inside the parentheses, we're going to do the opposite sign. So h, the x-coordinate of the vertex, is always going to be the opposite sign of whatever's inside the parentheses since there's a minus sign there. Then for the axis of symmetry, we know that, or we learned the other day, that the axis of symmetry is just the x-coordinate of the vertex, which means the axis of symmetry is just going to be x equals whatever h is. All right, so let's take a look at an example. So we have f of x equals 2, parentheses, x minus 4 squared minus 2. So a is 2. And then we have h and k. Remember, h is the opposite sign of whatever's in the parentheses, so h is positive 4. K is negative 2. It's the same sign for K. So for the concavity, since A is positive, so A is greater than 0, that means we're concave up, which we can see from this graph here. It's concave up. And now the vertex is just going to be HK, so it's going to be 4, negative 2. Which we can see here from our graph, 4, negative 2. And then lastly, the axis of symmetry is just x equals whatever h is, so x equals positive 4. All right, now let's take a look at factored form. So factored form is f of x equals a, parentheses, x minus r1 and x minus r2. So again, factored form is going to tell us the concavity. It's the same rule as before. So if a is greater than 0, we know it's concave up. And if a is less than 0, we know it's concave down. And then what we're going to do is we're going to use something that we learned in the previous unit. We're going to basically use zero product property to solve for our x-intercepts or our zeros. So we're going to use zero product property to solve for zeros. So we're going to set one factor equal to 0, and then solve for x to get our zeros. All right, so looking at our example here, so we have f of x equals x minus 1, x plus 3. So a, if there's no number out in front, then a is just equal to 1. And since a is positive, it's concave up. And then for the zeros, I'm just going to use zero product property. So x minus 1 equals 0. And x plus 3 equals 0. And now I'm going to solve. So plus 1. So x equals 1. So one of my zeros is going to be 1, 0. And then here I'm going to subtract 3. So x equals -3. So my other 0 is going to be -3, 0. So when we write our zeros, it should be written in this form, whatever you solve for x, comma 0, and then the same thing for the other x-intercept. So looking at our graph here, we can see the concavity is up, and then we see our zeros at -3, 0, and 1, 0. All right, so lastly we have standard form. So standard form is f of x equals ax squared plus bx plus c. And standard form tells us 3 things, or 4 things pretty much. It's the concavity, the y-intercept, and the axis of symmetry. So for the concavity, just like the previous ones, we're just going to look at a. If a is greater than 0, we're concave up. If a is less than 0, we're concave down. So the same rule as the previous ones. For the y-intercept, we're going to look at c, and my y-intercept is going to be 0 and whatever c is. And then for my axis of symmetry, we're going to use the equation x equals -b over 2 times a. So that's going to give us our axis of symmetry. And then our vertex, the x-coordinate is just going to be whatever the axis of symmetry is. So -b over 2a. And then what we're going to do is we're going to plug in whatever we get for the axis of symmetry, so -b over 2a, to our function, and that's going to give us the y-coordinate. So plug in axis of symmetry to function to get y-coordinate. So let's look at an example. All right, so f of x equals -2x squared plus 4x minus 5. So a is -2, b is +4, and c is -5. So starting with concavity, since a is less than 0, it's concave down. My y-intercept is 0c, so it's going to be 0, -5, which we can see here from our graph. Now to find our axis of symmetry, we're going to use the formula -b over 2a. So plugging in, I have -4 over 2 times -2. So that's going to be -4 over -4, which equals +1. So my axis of symmetry is x equals 1, which we can see from our graph. And now to get our vertex, we're just going to plug in 1 to our function. So plugging in 1, we have -2 times 1 squared plus 4 times 1 minus 5. Now to simplify, we just need to do order of operations. So starting with parentheses and exponents, we have 1 squared, which is 1. And then we're going to multiply. So -2 times 1, this just is -2. And then 4 times 1 is +4 minus 5. And now we just go from left to right. So -2 plus 4 is +2. Minus 5 is -3. So this is the y-coordinate of my vertex. And we know the axis of symmetry is the x-coordinate, so my vertex is going to be 1, -3, which we can see here. All right, so now let's look at a couple of the practice problems. So starting with number 1. So for each quadratic, we're going to state the form and all the characteristics that we can based on just the equation. All right, so looking at number 1, this is written in vertex form. Okay, and vertex form tells us 2 things. It tells, well, 3 things. It tells us the concavity. It tells us the vertex, and it tells us our axis of symmetry. So concavity, we're looking at the letter A, which is 1/2, and since that's positive, it's concave up because A is greater than 0, or A is positive. The vertex, we are looking at H and K. So H is -2, K is 4, so my vertex is -2, 4. And my axis of symmetry is x equals h, so x equals -2. All right, number 5. Number 5 is also written in vertex form. And it's going to tell us 3 things: concavity, vertex, and axis of symmetry. So concavity, looking at A, since A is negative, it's concave down because A is less than 0. My vertex, so H is -3, K is -2, so my vertex is -3, -2. And my axis of symmetry is x equals h, so x equals -3. Remember, when doing these, you're only switching the sign of the number inside the parentheses. All right, number 9. This one is written in factored form. Factored form tells us 2 things. It tells us the concavity, and it tells us the zeros. So first, starting with the concavity, since A is positive, it's concave up. And then for the zeros, we're going to use zero product property. So x plus 5 equals 0, and x minus 7 equals 0. So solving for x, we get x equals -5, and x equals +7. So my zeros are -5, 0, and 7, 0. Okay, number 11, also written in factored form. So we know the concavity and the zeros. So for the concavity, since A is negative, it's concave down. And then for the zeros, we're going to use zero product property. So 2x plus 7 equals 0, and 3x minus 7 equals 0. Solving, subtract 7 and divide by 2. So x is -7 over 2. And then here we're going to add 7 and divide by 3. So my zeros are going to be -7 halves 0 and 7 thirds 0.